Hi everyone, welcome to our JC1 H2 Mathematics. We are currently in chapter 9, the chapter on functions, and we are doing this supplementary worksheet. Now, for this particular video, we will be going through some of the questions behind, and these questions over here are questions from other exam boards, right? So we are not really too much focused about the idea about the proof of the existence of an inverse function or even a composite function, but mainly to see what kind of algebraic techniques that we can use in order to solve problems involving functions, inverse, and their composite. Okay, so without further ado, let us jump right to the questions at the back. So let's take a look at question 1 over here. All right, so we have the functions f and g, right, being defined in this way. So remember, whenever we have function, there's going to be a rule over here, right, the formula, and the domain also, the domain defined for the function. Okay, so part A, we want to find the expression for each of the following functions, right? So we have part 1, f2, gf, and f inverse. Okay, so this part A, right, we are looking for the expression. Okay, so it means that this is going to be an algebraic kind of question where we just want to find the formula of what's going on. Okay, so let's take a look. How do we find f2 of x, right? So even though they write here f2, right, it actually means f2 of x, where x is the input. Okay, so what is f2 of x is, I'm just going to write it as f of x. Okay, so I'm going to take this first fx first, and this will be just f of 2x minus 3. Okay, so this is the first f. Okay, so the one that I underlined in purple will be replaced with the expression 2x minus 3. Okay, then I'm going to input this into the second f. So for the second f, it will be 2x minus 3. So it's to input this into the second function over here. So it is entire expression from the first f sub into the expression for the second f. So what we have over here would be just 4x minus 6 minus 3, so 4x minus 9. So this is the expression for f2x. Okay, so let's take a look at part 2. We are looking for gf of x. So in the same way, I'm going to replace this fx into 2x minus 3. So this would be g of 2x minus 3. Okay, now then I'm going to replace the expression over here. I'm going to replace this x with 2x minus 3. Okay, so this would be 2 over x, or the x is namely just 2x minus 3. So this would be part 2. Okay, now part 3 over here, we are going to look at f inverse. So for f inverse, right, we will need to let y be equals to that, right? So I'm going to let the output y. So technically it's like this. So we are starting from x from the domain, right? So when we map this over here, we will be getting y. Okay, so in order to find the reverse, I will let the output y be equals to the whole expression 2x minus 3. So in order to look for the x, we need to make x the subject. So over here, x will be equals to y plus 3 over 2. Okay, so with this, right, I can now replace. Okay, so the concept is like this, right? So f of x is equals to y, right? In a sense, x would be equals to f inverse of y. Okay, so technically speaking, I will just replace this x with, okay, this skippable step over here. So f inverse of y is equals to y plus 3 over 2. So what I'll need to do next is just to replace this y with the x, right? In order to get back the x as the input. So f inverse of x would be x plus 3 over 2. Okay, so for this particular question, right, I think it's mainly just an exercise on getting the expression. So we are not too concerned about the domain of this particular function. Okay, but in fact, right, the domain of this function is actually also the whole of real numbers. So let's say if you can see what's going on, right, you can actually see that the domain would be x in x is a real number, or x is an element in the real number set. Okay, so this is for part A. Okay, so let's take a look at part B. Okay, part B, right, we have to calculate the value of x such that f2x equals to gf of x. Okay, so over here, right, because since we have already calculated what, or actually like determine what is f2 and gf, so what we'll do is we'll just do the substitution straight away. Okay, so f2 is actually 4x minus 9, right? Gf of x would be 2 over 2x minus 3. So what we'll do is we will be multiplying them. So try to solve for x because we are calculating the value for x. Okay, so over here 8x squared, when I expand, minus 30x plus 27 equals to 2. Okay, getting this out over here, I will get 25. Okay, so factorizing this will give me a 4x minus 5 and a 2x minus 5. Okay, so with this from here, okay, x will be equals to 5 over 4, or x will be equals to 5 over 2. Okay, and we'll double check and see that actually since x is non-zero, okay, so we can actually input this in f and it will be safely input into g as well. Okay, so so once again, right, when we do questions from other exam boards, or even like questions from other O levels, right, or IGCSE, the thing is that we were not too concerned about the domain back then. Okay, so sometimes it may be confusing because the domain doesn't match, but I think most of the time, I think like using the knowledge that we have, it's good to be aware about the domain. But I think for this particular video, we'll focus on the algebraic skills. Okay, now then use your analytical brain to think further about the domain. Okay, so we'll have that mindset for this particular video. Now let's proceed to question 2, right? We have functions f and g are defined like this. So fx and gx each with their rules and the domain that they are defined on. Okay, so let's take a look at part A. Now we haven't proved that f inverse exists, but checking the domain, f inverse do exist lah. Okay, all right. So over here we are looking for f inverse of 2, right? So what we will do is now, so there are two methods, right? So the first method would be the more direct method, right? So the first method will require us to find the explicit expression for f inverse first. Okay, then what we'll do is we'll substitute x equals to 2 to evaluate the answer. Okay, so that one will be a very easy task for this particular question, but I'm going to share with you what is method 2 instead, if we have a case where like if you have a case where f inverse is not easily obtainable. Okay, so let me show you what is this concept over here. All right, so now currently we have the function f, right, that brings an object to 2, right? So when we take f inverse over here, we are trying to look for this particular unknown, right? We are trying to look for the particular unknown x. Okay, so then, right, what we'll do is I'm going to let f inverse of 2 to be equals to x. Okay, and then I'll take the inverse of this function on both sides. So I'll just put f and f in front. Okay, so f and f inverse will cancel. So this 2 will be equals to fx. Okay, so it is like sine theta equals to half, theta is equals to sine inverse of half. That kind of concept. Okay, so making use of the inverse, throw the f inverse to the other side, I will just need to solve for fx, and I don't even need to find the whole expression for f inverse, right? So this is technically a faster method to do things. Okay, so over here 2 is going to be equals to 3x minus 2. So 3x is going to be equals to 4x will be equals to 4 over 3. Okay, so very, very easy. So I think to conclude a little bit, so f inverse of x, sorry, f inverse of 2 would be equals to 4 over 3 like this. Okay, so this is how we make use of the concept of the inverse, right, to evaluate f inverse of 2. So we don't have to find the explicit expression for f inverse to do this. Okay, so let's take a look at part B. We are looking for g f of negative 3. Okay, so the first thing that we'll do is we need to evaluate what is this f of negative 3 first. Okay, so let me attempt to evaluate this. So this will be equal to g of, okay, 3 times negative 3 minus 2. Right, so evaluate the number inside this bracket. So this would be equals to negative 11. Okay, so subbing in negative 11 into this formula 3 over x. So the x now input is negative 11. So writing it nicely will be negative 3 over 11. So this will be the answer for part B. Okay, now let's take a look at part C. Okay, for part C, the function h if h of fx is equals to 3x plus 2. Okay, now for part C, right, this is very interesting. Okay, or let me clear this board over here first. Okay, so method 1, right, is to make use of the property where f and f inverse of x is equals to f inverse and f of x equals to just x. So when you have a function where you take the f and composite with the f inverse, you're going to get back that particular element over there, right? The particular input x, okay? So we're going to make use of this to get rid of hf of x, okay? So starting with hf of x equals to 3x plus 2 . Okay, so what I will do is, okay, sorry. Okay, what I will do is this. So actually hx will be equals to hf, and I'm going to put f inverse beside f. Okay, so something like this. Okay, so this is my goal of the day. I need to find f inverse such that I can sub f inverse into h of f to get back my hx, because this one will cancel each other and give me back my x. Okay, so this is the direction that I'm going to go. Okay, so putting this one side first, let me find my f inverse now. So I will let y to be equals to 3x minus 2. So y plus 2 over 3 is equals to x. So skipping some steps, right? Skipping some logical steps. So this tells me that f inverse of x is equals to x plus 2 over 3. Okay, so this is my f inverse of x. So now putting this into the this hf. So hf is actually, okay, so hf of f inverse. Okay, so hf of f inverse over here. Okay, then now I'm going to substitute this f inverse, substitute into this expression over here. Okay, so hf is 3x plus 2. So I'm subbing in x plus 2 over 3. So simplifying this, I will get x plus 4 as my expression for hx. Okay, so this is going to be method number 1. Okay, so method number 1. So method number 1 once again is to make use of the fact that f inverse f, right, will give me back x. So what I'll do is, in order to look for hx, I will start with hf and I will put the inverse beside f so that I can sub in and get back my hx like that. Okay, now the second method over here, right, is largely similar, right? The mechanism is like finding the inverse. Okay, it's just that the presentation will be a little bit different. Okay, so I'm going to start with hf of x equals to 3x plus 2. Okay, so first, right, what is fx? So I will put h of 3x minus 2, right, into this output over here. So over here I get 3x plus 2. Okay, so something like this. Okay, so I will let y to be equals to this input first. Okay, so let y equals to 3x minus 2. So x is going to be equals to y plus 2 over 3. Okay, so the next step is to replace this one with y. So I have hy over here, and I will replace x with this expression over here. Okay, so y will go here, this will come here, right? So this one over here will be equals to 3 times of y plus 2 over 3 plus 2. So this is actually equals to x plus 4, exactly like the answer that we found earlier. Okay, so once again, now method 2 is actually very similar to method 1 in terms of the mechanism. It's just that the presentation is a little bit different. Okay, but for method 1, right, is a bit safer because we are making use of this property f and f inverse. Okay, will cancel each other out. Okay, so this is how we find hfx, how to find function h from hfx. Okay, so let's continue this with part D. Right, over here I'm going to look for function k if the composite fk of x equals to 4x minus 7. Okay, so in order to look for k of x, where do I need to put my f? I need to put my f beside the, I need to put the f inverse beside my f. Okay, so this is going to be the way I will do this question lah. Okay, which is to sub in f and f inverse to get rid of the f. Okay, now so I will have f inverse of 4x minus 7. Okay, so borrowing the expression for f inverse previously, we had x plus 2 over 3, right? So this would be our x, okay, so x plus 2 over 3. Okay, so with this, kx will be equals to 4x minus 5 over 3. Okay, so this is the expression for part D. Okay, seems easy enough. So it's just substituting the 4x minus 7 into the f inverse. Okay, so that is method 1. Now, so let's go through method 2. So method 2, right, is also a bit interesting. Method 2 is also substitution. So starting from fk of x equals to 4x minus 7, right? So the thing over here is I'm going to substitute the kx into this fx, the expression for fx over here, right? So what I'll have is f, right, is actually 3x minus 2. So substituting kx into this expression, I get 3kx minus 2 equals to 4x minus 7. So making kx the subject, so over here I get 4x minus 5 divided by 3. Okay, so make kx the subject, then I will get back the same expression, okay, for kx, like that. Okay, so two different methods, all right. One is making use of the f inverse. The other method is to just sub in the k into the f over here. Okay, so C is actually the tougher one in my opinion, right? But as long as you know this concept, I think it should be very straightforward. Just that maybe a little bit long. Okay, but for method 2, right, now C would be the harder one, then D would be the easier kind of question. Okay, so hope you take note about this for question 2. Okay, let's continue to question 3. All right, so question 3 is given that fx is this expression over here, and f square of x, or f2 of x is this expression over here. So we want to find the value of h and k. So the only thing we can do is to composite f, and we're going to compare terms to solve for h and k. Right, so let's try for this one over here. So f2 of x, right, will be equals to f of hx plus k. Okay, and with this would be hx plus k. So putting in the input hx plus k over here, we are going to get a h square x plus hk plus k. Alright, so what we're doing is we're going to compare with this 4x plus 15. Okay, 4x plus 15. Okay, so when we have this, okay, so comparing terms, okay, comparing terms between this and this. Okay, so the first one over here, h square is equal to 4. So h will be equal to plus minus 2 since there's no restriction on h. Okay, now then let's check out the other part over there. Alright, so when h is equals to 2, so we have 3k equals to 15, k is equals to 5. Okay, and when h is equals to negative 2, so we will have a negative k equals to 15. So k will be equals to negative 15. Okay, so this is how we will solve for values of h and k in part A. Alright, so for part B over here, for values of h more than 0, so means we'll take this package over here. Okay, so this tells me that my h is going to be 2, k is going to be equals to 5. So we're going to take this set of values, find the values of x for which fx squared equals to 7x. Okay, so what we'll do first is we are going to form back our fx first. So fx is going to be equals to 2x plus 5, like that. Okay, with this, right, now I'm going to sub in when x squared sub into f, I will get 7x over here. So given f of x squared is equals to 7x, so I will sub this x squared into this expression over here. So I will get a 2x squared plus 5 is equals to 7x. Okay, so making this the subject, or making all the x at one side because it's quadratic. Okay, so it will be something like this. Okay, so x over here will be equals to 5 over 2, or x is equals to 1. So two possible answers for x. Okay, so this is how we solve question 3. Okay, continuing to question 4, now we have function f, and the domain of f is such that x is not equals to 1. We are supposed to find f2, f3, f4. Okay, so let's do this first and we will state that later. Okay, so first let's find out what is f2 of x. So f2 of x would be just f of this whole thing over here. Okay, so this would be equals to 1 plus x. So 1 plus whatever input that I have over 1 minus whatever input that I have over here. Okay, so now making this fraction, so making common denominator, so 1 minus x plus 1 plus x, okay, all over 1 minus x on top. Now, and then at the bottom, I will get 1 minus x minus whole thing bracket 1 plus x. So this one, be careful. Okay, very common error. Okay, so we have two fraction upon fraction. So this roughly tells us that these two will cancel out. Okay, the denominator. Okay, so with this, right, let's simplify what's going on up here. We are going to have 2 on top, and we will have minus 2x below. So this is going to be negative 1 over x as f square x. Okay, now let's take a look at how do we evaluate f3 of x. So f3 of x, right, is just simply, right, f of f square, or actually I can do f2 fx. Substitute fx into the f2. So what is fx again? So it's f2 of this. Okay, so f2, right, over here we evaluate already, or gotten the answer already. This is negative 1 over x, the negative reciprocal. So what we're going to do is we're going to do the negative reciprocal over here. Okay, so if we want to really simplify, so this would be something like this, x minus 1 over x plus 1, where we will expand this set over here. Okay, altogether this would be x minus 1. Okay, so this is f3. Now let's continue on to what is f4. Right, so f4 of x, right, is actually f square, f2 and f2 of x, if you think about it. Okay, I think this is an easier way to do, unless you can also try f and f cube. Also can, right? So you get a very complicated fraction, which is a bit weird. So over here, we will get f2 of negative 1 over x. Okay, so we take the negative 1 over this thing over here. Right, so with this, we are going to have b equals to x. So this is going to be f4 of x. Okay, now, so let's take a look at the next one. We're going to find f of 2025 and f of 2026. So f of 2025, right, is actually equals to f and f of 2024 of x. So this is actually still equals to fx. So over here, this will be equals to 1 plus x over 1 minus x. Okay, now then f 2026, right, of x, right, so this is going to be f square of f 2024 x. So this is just simply f2 of x, and what's f2 of x is just negative 1 over x. Okay, at the final answer over here. Oops, okay. I think let me write below so that it's easier. Okay, so something like this. Okay, f2 of f 2024, right? So this one is just replaced with x, and then we'll get f2 of this, so which is equals to negative 1 over x. Okay, so this is how we make use of the all these properties, right, to make it easier to calculate the big composite functions. Okay, so this is for question 4. Okay, so moving on to question 5. Given that fx follow this rule over here, and this is the domain of x, and gx will be this rule, find the value of m. So in order to find the value of m, which is in the denominator, right, we'll need to make use of the denominator being undefined when x is equals to 3 over 2. Okay, so the thinking statement is going to be like this. Okay, so this one would mean that the mx plus 3 is equals to 0, and m of 3 over 2 plus 3 is equals to 0. So solving for m would be equals to negative half. Okay, if I am not, sorry, negative, okay, this one is going to be equals to, okay, sorry, my bad, minus 3. So minus 3 minus 3. So this one would give me a value of 2. Okay. Okay, moving on to part B. Now we have GF inverse of negative 2. What I'll do first is I will find the explicit expression for F inverse first. Okay, so first I will let Y, right, to be equals to fx, which is equals to 5x over now become 2x really, so 2x minus 3. Okay, so making x the subject, so I got 2xy minus 3y equals to 5x. Then x 2y minus 5 is equals to 3y, so x will be equals to 3y divided by 2y minus 5. Okay, so something like that. So because of that, right, okay, the final answer for part B will be, sorry, not final answer yet, f inverse of x would be 3x over 2x minus 5. Okay, what we're going to do next is we're going to look for GF inverse of negative 2. So it means that I'm going to sub in the negative 2 into this expression over here first. Okay, so this would be g of negative 2 will be negative 6 divided by negative 4 minus 5, so this will be negative 9. Okay, so altogether we have g of 2 over 3. So next is to sub in 2 over 3 into the expression of this one over here. Okay, so we will have 3 minus 4 of 2 over 3. Okay, so with this, right, all together we are going to get 1 over 3 as our final answer for the GF inverse of negative 2. Okay, part C. Now part C, we are looking for function h if hgx equals to this. So I'm going to use the method 1 that we did just now, which is to find g inverse first. So first, I'm going to let y to be equals to the gx, which is equals to 3 minus 4x. So making x the subject, y would be equals to x equals to 3 minus y over 4. And with this, g inverse of x is equals to 3 minus x over 4. Okay, so having this expression in mind, right, my hx is going to be equals to hg of g inverse of x. Okay, so with this over here, this would be hg of this whole fraction. Okay, and I'm going to sub this into hg, which is 12x plus 5 over here. So this one over here would be equals to 12x, okay, plus 5. Right. So then making this simplifying this, so I will get 9 minus 3x plus 5. So this is 14 minus 3x. Okay, so this one over here would be our answer for hx. Okay, so there we have it. This is question 5. Now let's press on with question 6, where we'll look at IGCSE question. Okay, so over here, this one function f is defined as the logarithmic function over here for x more than 8. So once again, right, for a log function, right, it is defined, right? So this is defined when the content of the log is more than 0. Okay, so we're going to make use of this property to find our x over here. Okay, so a part 1, right? Write down the value of a. So for f to be defined, okay, the content, so this means that 5x plus 2 is going to be greater than 0. So x must be greater than negative 2 over 5. So this means that the value of a, okay, this value over here is going to be equals to negative 2 over 5. Okay, so this over here is part 1. Okay, part 2. Okay, hence, find the range of f. Okay, so this one over here, we need to remember the graph of lawn. For a lawn graph, right, the general shape is going to be like this. Okay, so we have an asymptote over here at x equals to negative 2 over 5. But then we get a whole range of graph over here. Okay, so this over here would be the domain, right? Then all the vertical values would be the range of f. You see this, right? So what is the range of f? So this range of f, right, is just simply the whole of the real number line, like that. Okay, so find f inverse, stating its domain. Okay, so part 3, in order to find f inverse, so I will let y to be equals to ln of 5x plus 2 to be equals to this function over here. Okay, to be equals to this function over here. Okay, so what I'll do is, okay, sorry, let me use another color. Okay, so what I'll do is I will make x the subject. So e power y would be equals to 5x plus 2. So x would be equals to e power y minus 2 divided by 5. So my f inverse of x, the expression would be 1 over 5 ex minus 2. Okay, so what is the domain over here? The domain is actually, now, concept domain of f inverse is equals to the range of f. Okay, so what was the range of f just now? Whole of the real number line. Okay, so this is how we get part A, A's part 1, 2, and 3. Okay, so now that we've done with part 1, 2, and 3, so we're going to continue on with part 4. So on the same set of axes, we are going to sketch the graph of f and f inverse. Now stating the exact values of the intercepts of the curve with the coordinate axis. So roughly we got a rough sketch over here already. Okay, so what we're going to do is we're going to draw y equals to x, and we're going to draw the reflection from there. Okay. Okay, so getting the axis ready. All right, so first let us try to draw fx, which we've already done over here with a rough sketch. Now we are going to draw this properly, okay? So the first things that we need to include is the asymptote over here at negative 2 over 5. Right, we have the asymptote over here. And after that, we are going to draw the graph, right, passing through the x and y axis. Okay, which will obtain a graph something like this. Okay, so the next thing that we need to add is we're going to add a special line, and the special line is called y equals to x for this rotation. Okay, so what we'll do, so for this reflection on y equals to x. So roughly we are going to get this line over here, right? So I'm going to extend the line like this. Okay, so this one over here would be the line of y equals to x. This one, y equals to fx. Okay, so how would the inverse look like? It is actually this purple graph reflected along the, what do you call it, along the line y equals to x, which will look something like this. Okay, so getting the vertical axis shift to horizontal axis first. Okay, so this one from x, right, it becomes y equals to negative 2 over 5. Okay, and then it swerves this way, right? So I'm going to swerve the other way, something like this. Okay, okay, so something like this. And then this blue color graph would be y equals to f inverse of x. Okay, so now let's try to label the axial intercepts. Okay, so first one over here, this one is actually ln 2. Okay, and when y equals to 0, right, so this one over here will be negative 1 over 5 with some algebra. Okay, so in the same way, I suppose that this one over here would also be ln 2, and this one over here would be negative 1 over 5 as well. Okay, so this is how we label, all right, we sketch the graph of f, f inverse, and also labeling the axial intercepts. Okay, so if you have a turning point, then you have to label that turning point as well. Okay, so this is the answer for part 4. Okay, so let's continue on with part B, and I think they don't have any relationship with part A lah. It's just a standalone thing. Okay, so the function g is such that like that for x more than 0, solve the equation g2x equals negative 2. So we need to look for g2x first. Okay, so g2x will be equals to gg of x. So what is gx in the first place? Gx is actually this x power half minus 4. I will write this as square root of x minus 4. Okay, so subbing this in, right? So I have a square root of x on the outside minus 4, and I will put this inside. So x minus 4 like this over here. Okay. Okay, so what I'll do this is I will now equal this to negative 2. Okay, right? Because g2x equals to -2, so I'll just equal this to -2 and try to solve for x. Okay, so moving the 4 to this side, so 2 square is going to be equals to square root of x minus 4. So this will be 4 on the left. So square root of x will be equals to 8. Okay, so continue on. So x, when you square back, so x will be equals to 64. Okay, there's no plus minus 64. This one is something for you to figure out. So there's no plus minus, it's just simply 64. Okay, so this is how we will do question 6, part B. Okay, so now we are currently in question 7, and this is actually a very standard A-level question, even though this is not our exam board, but still pretty standard. Okay, so part 1, we want to express this quadratic equation in the completed square form. Okay, so what we'll do is, now I will try to complete the square for this. Okay, so doing some Sec 2 math or Sec 3 math, right? I managed to get this out, right, to complete the square. So it's mainly 9x squared and this. So this one, I hope you've seen the multiplication frame before. Okay, so it's really to complete this, help me to complete the square in a very nice way lah. Okay, oh sorry, this one need to delete. Okay, actually it doesn't matter. So this one over here will be equals to 3x minus 1 square plus 5. So A is 3, B is -1, C is 5. We don't need to state lah. Okay, they just tell us that we want in that form. Okay, so this is for part 1. Now, then for part 2, the function f is defined by this for x greater than p. So this is the one that we need to take note. Okay, where p is a constant. Okay, so state the smallest value of p for which f is a one-to-one function. Okay, so let's imagine this for part 2 over here. Now, this 9x squared and so on, right? This is actually a positive quadratic graph. Okay, right? So which part from the right hand side are we going to take such that we'll get the maximum one-to-one function? Okay, so technically speaking, we'll need to start from here lah. And we will need to ignore the part of the graph which is on the left hand side, which is here. Okay, we'll need to ignore this part of the graph. Okay, so what we'll do is, okay, we'll need to identify what is this point. And this point, right, we can actually get from part 1. And this is actually 1/3 and 5. Like that. Okay, so now would be domain, right? Domain of f would be like this. Okay, and then the range of f would be like this. Can Alright, so for part 2, let us state what is the smallest value of p. So the smallest p would be the smallest x value, which is going to be equal to 1/3. Okay, so for this particular value of p, obtain an expression for f inverse of x and state the domain of f inverse. Okay, so how do we get the f inverse? Is we need to make x the subject, but the problem is we cannot make x the subject like this, so we have to depend on the completed square form. Okay, so I will let y to be equals to this completed square form over here, right? So 3x minus 1 square would be equals to y minus 5. So 3x minus 1 would be equals to plus minus square root of y minus 5. Okay, so plus y minus 5 or minus y minus 5. Okay, so then I will need to make x a subject. Continue make x a subject. So this is going to be 1/3 of 1 plus square root y minus 5 or 1/3 of 1 minus this value over here. Okay, so double checking, right, the range of the range of x, right? So x must be greater than 1/3, greater than or equal to 1/3, correct? So means that when I have this over here, right, is considered greater than 1/3. This one 1 minus this, so it will be less than 1/3. Okay, so what is going on here is I'm going to accept this I'm going to reject this because x is greater than 1 over 3. Okay, so with this, right, the expression for f inverse of x, right, is just to change all the y's back to x because we just borrow and do this. Okay, and the domain of f, right, is the range of, a domain of f inverse would be the range of f. So this one over here would be x greater than or equals to 5. Okay, so concept again, so the domain of f inverse, it will be equals to the range of f. Okay, so something to remind you, okay, for this concept. Okay, last but not least, state the set of values of q for which the equation fx equals to q has no solution. So this means that we will be looking at y equals to q. You see this? Right, y equals to q. So this is actually a horizontal line. So where will the horizontal line be such that there's no solution is where the horizontal line is below the graph. Let's say if we have something over here, we have an intersection, and with an intersection, we actually have a solution. So if the graph is below, that means, if the line is below this curve, so that there are no intersection means there will be no solution. So this tells me that, right, the range of value of y, right, so y, or actually more like q lah. So q must be less than 5. Okay, if it's equals to 5, you will touch that curve, but strictly less than 5, right, coming from this value over here, would be the best, right? So q must be strictly less than 5. Okay, so now all this over here, right, is to go through once again like the algebraic techniques for functions, right? Hopefully this is insightful for you and very fruitful for your learning. All right, if there's anything that you're unsure of, please consult your tutor. All right, and all the best studying for functions. Okay, so now this will form the algebra part. You also need to get use of the proof on why a function has an inverse and why the composite exists. Okay, so this one is for you to continue to follow up. All right, so that's all for this video. Right, so take care, all the best.